Hello friends, my name is Masood. Today we shall discuss about topic edge computing in cloud computing. Friend, today's topic is very interesting, especially if you have interest in cloud computing and you want to learn about it, and especially you have interest in edge computing. Friend, edge computing is a paradigm in computing where data processing is moved closer to the edge of the network, closer to the source of data generation or consumption, rather than relying solely on the centralized cloud servers. This approach is designed to address the limitations of traditional cloud computing by reducing latency, improving real-time processing, and enhancing overall efficiency. So basically, friend, it is a new concept in cloud computing that is called as edge computing. Uh, Edge computing is a distributed computing paradigm that brings computation and data storage closer to the source of data generation, reducing latency and enabling real-time processing. It involves processing data at or near the edge of the network, often on devices or gateways, rather than relying solely on the centralized cloud servers. If we talk about key characteristics, first one is the low latency, means that edge computing minimizes the time it takes for data to travel from the source to the processing center, resulting in low latency. This is crucial for applications requiring real-time responsiveness such as IoT devices, autonomous vehicles, and augmented reality here as well. Then bandwidth efficiency means by processing data locally, edge computing reduces the need for transmitting large volumes of data to centralized data centers. This not only conserves bandwidth but also reduces the associated cost here as well. Then distributed architecture means that edge computing involves a distributed architecture where processing power is distributed across various edge devices or edge servers. This decentralization enhances the scalability and the resilience. Applications that require real-time decision making, such as industrial automation and critical healthcare systems, benefit from edge computing's ability to process data on the spot without relying on round-trip communication to a distant cloud here as well. Then, we can talk about the major components of edge computing. First one is the edge device. Basically, friend, these are the endpoints where data is generated or consumed. Examples include IoT devices, sensors, mobile devices. Like nowadays, many devices are available. For example, the air conditioners, the fridges, the doors, mobile devices. So all those are called as the edge devices. Then edge servers or gateways means intermediate devices that process and filter data before sending it to the centralized cloud. They act as a bridge between edge devices and the cloud. Then edge data centers means localized data centers situated closer to the edge of the network. They provide additional processing power and storage capacity for handling edge computing workloads. Now we can talk about the use cases. First one is the Internet of Things, IoT. Uh, Edge computing is a fundamental to IoT where vast amount of data are generated by sensors and devices processing data at the edge, reducing latency and conserves bandwidth here as well. Friend, IoT is normally different nowadays. Things are there, like for example mobile devices, the air conditioners, doors. So there are many things which are called as, which comes under the definition of Internet of Things. Autonomous vehicles, like edge computing enables real-time processing for applications like object detection and decision making in autonomous vehicles where split-second decisions are crucial for safety. We know that nowadays autonomous vehicles are coming in the market, like the vehicles like a car without a driver. Here very important thing is that how a car will be driving without a driver, like they are basically using the data through the edge and they are taking the decisions in a split of a second, in a nanoseconds you can say. Then edge computing supports various smart city applications here, as like for example including traffic management, surveillance and environmental monitoring. like traffic will also be used, will also be managed through the edge computing and through the cloud computing here as well. Then augmented reality and virtual reality means these applications benefit from edge computing to reduce latency, providing a smoother and more immersive experience here as well. Then challenges and considerations means distributing processing closer to the edge introduces new security challenges. Ensuring the security of distributed edge devices and data is very crucial here as well. Another is the challenge is the standardization means the edge computing landscape lacks standardized protocols, leading to interoperability challenges. Efforts are ongoing to establish common standards for seamless integration here as well. Then the management and orchestration mean managing a distributed network of edge devices and servers require sophisticated orchestration tools to ensure efficient operation in the case of edge of computing. Now we can talk about the industry trends which are nowadays common and we must have to discuss about it. First one is the 5G integration. Friend, I'm sure that you have heard about 5G in many cities, in many countries. 5G is coming and they are rolling outwards. So, the edge of computing will be integrated with the 5G here as well. The role of 5G network enhances the capabilities of edge computing by providing high speed, low latency connectivity. Here, friend, we know that cloud computing is totally dependent on the internet. So obviously if there is a connection of 5G, so which is a very great connection with a very high speed, so it will basically, due to high speed, it will be helpful for the edge of computing here as well. Then AI at the edge means artificial intelligence means edge computing often integrates with artificial intelligence for local decision making, reducing the need for sending raw data to the central servers for processing. AI will helps you a lot in the edge computing and it will become a very important aspect in the edge computing. Then hybrid cloud and edge architecture means many organizations are adopting hybrid architecture. Hybrid cloud that combines centralized cloud computing with edge computing for a balanced and a flexible approach. Whenever we talk about hybrid approach, basically friend, we are basically talking about private cloud and the public cloud capabilities, like both clouds will be integrated with each other and it will be integrated with the edge computing here as well. So in conclusion, edge computing is a transformative paradigm that address the evolving requirements of modern applications by moving computation closer to the data source.